Special angles, very important, especially if you're going on in math. Okay, so math 30-1, math 31, you really need to know these special angles. So what's special about them? Well, how many special angles do we have? It's about like 5 of them, but we're looking at 3. 45 degree, 90 degree triangle is shown. Determine the exact value of the length of the hypotenuse. Okay, what's the exact value of the length of the hypotenuse? Root 2, right? Square root of 1 squared plus 1 squared. So this is the hypotenuse, so its length is the square root of 1 squared plus 1 squared, or root 2. Use the dimensions of the triangle to state the exact value of each of the following trig ratios, right? So that's what we're doing. These special angles allow us to get exact values, right? So we can get the exact value of the sine of 45 degrees. We cannot get the exact value of the sine of 43 degrees or 37 degrees, but we can get the exact value for 45 degrees. Okay, so what's the sine of 45? Here's 45. You fill in the you can say it out loud. It's like opposite over hypotenuse, which is 1 over root 2, which is root 2 over 2. So most of the time we're going to want it as root 2 over 2. Sometimes strategically it's better to use it as 1 over root 2, right? Like if we knew we were going to divide by sine of 45, so if I'm going to divide by that, then I know I'm going to multiply by the reciprocal. So it's better to leave it as 1 over root 2, so when you multiply by the reciprocal, you're going to flip it and then the root 2 is up top, right? If you divide by root 2 over 2, you're going to flip it, and then you're going to have a radical in the denominator, and you'll have to re-rationalize it. So instead of rationalizing twice, we'll do it once, right? So just a little strategy. What's the cos of 45? 1 over root 2, which is root 2 over 2. And what's the tan of 45? 1. Can you write 1, right? Just 1. That one should be easy to remember, right? Tan of 45. At some point, you are going to have to memorize these, right? That point is probably not this year, but next year you will have to know these special angles, right? And if you walk into a 30-1 class or a 31 class and they're saying, you know, what's the sine of 45? People are saying root 2 over 2. So you just have to know them. The 30, 60, 90 triangle. 30 degree, 60 degree, 90 degree triangle is shown below. Determine the exact values of x and y. Use the diagram below right. So what we started out with was an equilateral triangle, right? 60, 60, 60. So what's the length of each of these sides? The same, and it is 2. It's like pulling teeth, right? Go get a pair of pliers. So what's the length of x? 2. So we start with, so the idea behind, right, 45, 45, 90, the idea is this is an isosceles right triangle. We arbitrarily chose the length of those sides to be 1, and then we worked out the hypotenuse, we got root 2, right? And we could have chosen it to be 10. Then you'd have 10, 10, and you've got the square root of 200. It would still eventually simplify to root 2 over 2, right? No matter what length you chose. So here, we start with an equilateral triangle. And we arbitrarily choose this length to be 2. Why? Well, so that this length is 1, right? I mean, if we call this length 1, then this becomes a half. And then the math just gets a little more difficult, right? We introduce some fractions we don't need. All right, if this is 1 and this is 2, what is y? Square root of 3, root 3, right? So everybody okay? Just write down root 3. Well, let's show it. So I want to get y. So it's going to be the square root of 2 squared minus 1 squared, right? 2 because that's the hypotenuse, so 2 squared minus 1 squared, which is root 3. So now we have a 30, 60, 90 triangle, right? That's going to allow us to do the sine, cos, and tan of 30, and the sine, cos, and tan of 60. So, use the dimensions of the triangle to state the exact value of each of the following trig ratios. So what's the sine of 30? So now you're looking here, there's 30. What's the sine of 30? 1 over 2. What's the cos of 30? I don't like root 3. Yeah, root 3 over 2. What's the tan of 30? One over root 3, or root 3 over 3, yeah. See, look, skills now. You have skills working with radicals you didn't know you had. Okay, I can rationalize the denominator just by looking at it, right? Because I'm just going to say root 3. It's root 3 over 3. What is the sine of 60? Now you're looking at 60. Which side is opposite 60? So root 3 and hypotenuse is 2. Cos of 60? 1 over 2. And the tan of 60? Root 3 over 1, just root 3. Now, what do you notice about the sine of 30 and the cos of 60? They're the same. What do you notice about the sine of 60 and the cos of 30? Or sorry, the cos of, yeah, and the cos of 30. They're also the same. I think this might be brought up. I might be foreshadowing. But do you know what cosine stands for? The co? What's the co in cosine? Complementary. What are complementary angles? Wow, you're looking nice today. That shade of yellow is lovely. Cool shirt. Right. Or, what are complementary angles? Okay, that wasn't nice. Complementary angles are angles that add to 90. Supplementary 180, complementary 90. What's the co and cosine? Complementary sine. The cosine is the sine of the complementary angle. The cosine is the sine of the complementary angle. The cosine is the sine of the complementary angle. Right? That's to memorize now, right? If you know sine 30, you know cos 60. If you know sine 60, you know cos 30. So you only have to know one of them. Right? There's other tricks. So there's this thing I think we're looking at Monday called the unit circle. You're going to have to memorize it at some point. But you're going to have to do it in radians, which is okay, which is until next year. I really think we should do radians this year. Complete the following chart using exact values. Okay, so the sine of 30 is half, right? It's on the same page, isn't it? You can just sort of look down and fill it in. I'm going to do this from memory. 45. And 60. Well, that's just a kind of reversal change up. Okay, you have to memorize this table at some point. I don't think the point is now. Well, actually, you might have to know them now. It's valuable. Yeah, okay, memorize this table. Might as well learn it now. Save a little wear and tear. Myelinate those pathways before Math 30-1, right? Then you can walk in and say, I don't remember it exactly, but I knew it, and it'll come back a lot faster, right? Okay. What else is there? Determine the exact value of each indicator. The exact value. Now, if by the end of this course you can accomplish two things, I will be semi-happy. Those two things are when you square a binomial, you get 3 terms, right? Or 4, yeah, if you square it, you have to get 3, right? Because you're just going to double up on 1 term. So if you square a binomial and you always get 3 terms, I will be happy. And if you understand the meaning of the word exact, and you never give me decimals when it's exact, unless those decimals are 0.5 or 0.75, which are also exact, then I will be happy, right? So exact value means likely there's going to be a radical involved, or pi, or e. You don't know e yet, but when you learn e, then that would be exact value. It would use this thing, right? So exact value just means put your calculator away. Okay. You don't need it. It can't help you here. Okay, so what do we got? Each indicated side. So in relation to the 30 degrees, let's name sides. What's x? Adjacent. What's y? And what's 12? Hypotenuse, right? Okay, so we have adjacent and opposite and hypotenuse, and we want the exact values. So, what do you want to start with, adjacent or opposite? Sines? Do you want to start with opposite? Okay, so here's what we're going to do. You said, I want to start with sine, okay, or just pick a ratio, because I want to start with sine. So what is sine? So sine theta is opposite over hypotenuse. Right? You know me, I like formulas, right? Write down the formula. You can substitute it into the formula. Write down the formula, right? That way we know what you're, then you're communicating to somebody. Look, I know that this is a geometric series or something, right? Because that's the formula that I'm giving you. Okay, sine theta is opposite hypotenuse. What do we know? Well, we know the 30 degrees. So sine 30 degrees is equal to what's opposite? That's y, and hypotenuse is 12. Okay, remember the secret to math, formula, substitution, answer. Well, there's a little bit of work to do here. So what's the work we got to do? Well, the sine of 30 is a half, right? So what's y? By inspection. 6, right? Do you need to see it solved more algebraically? No, right? I mean, it's a 1 there, right? How'd you go from 2 to 12? Multiply by 6? 6. So y equals 6. Okay, you could write 2y equals 12, and then write y equals 6. Now, we might have to do that if there's like a root 3 over 2, then we'll do the cross multiply thing, but for this. Cos. So the next one is cos, right? The cos of 30. Sorry, let's start off. Cos of theta is adjacent over hypotenuse. All right, every time you write that down, you're laying down a little myelination along a pathway in your brain that relates cos to adjacent over hypotenuse, right? You kind of know this, but so your brain is lazy, right? So if you are going to keep doing this, then I don't want to work that hard at doing it, right? So I'm going to create a pathway, a strong pathway, which means that I can just recall it as, what's 8 times 7? I don't know, or 56, right? So if 56 popped in your, if I say 8 times 7 and you see 56, what happened? You're just recalling that as a fact, right? You are not saying, oh, 8 times 7, so that's 8 groups of 7s. I've got a 7, 14, 21, no, you know it's 56, right? Or you should. This, what is that, type 1 and type 2 thinking, slow thinking. I don't know if it works into fast thinking, slow thinking, but it's just, there's facts you know, right? When you first learn to drive a car, that's where you're, like, everything is new, and you are really, like, all over the place, right? Like, gotta look in the mirror, gotta do this, gotta do that, right? After a few years of driving, it's pretty automatic, right? You're still handling the exact same tasks, right? You're doing a lot of complex mathematics in your head. What is the rate of approach of that vehicle, right? You're trying to judge that. Can I turn left? Is it safe to do so? Etc. Especially if you're on a motorcycle. If you turn left in front of a car, they'll hit you. Cos 30 degrees is equal to adjacent, which is x over 12. The cos of 30 degrees, which you don't know but I do, is root 3 over 2. Okay? And you will come to know, right? So you do have to memorize this at some point. And this one we will solve by going, so 2x is equal to 12 root 3, so x is equal to 6 root 3. And those are exact values. Like 6 is kind of obvious it's exact, right? You don't have to do anything with that. And 6 root 3 is exact. Put away the calculator. You see the word exact? Put away the calculator. Right? Questions? Right? You know how we ask stuff like this, right? The exact value is written in the form a root b, the values of a and b, right? Or the value of a plus b. Please read the questions, right? If we say a plus b, it's 9. If we say a goes here, b goes here, it's a 6 and a 3. You know, if you mess it up, at least show the work that says, look, I solved this, and I didn't read the thing, can I have a half a mark? You know, maybe. Oh, wait, there's more on the same page. Okay, you do B. Can we get a 10? Close to 30 degrees is adjacent, which is x, over hypotenuse, which is y. Wait a sec. So I don't want to do that. How about this? Y squared is equal to x squared plus 15 squared. Just go back to the Pythagorean theorem, right? Because otherwise I'm working with two unknowns. Well, sorry, no, never mind, we could do it. You can do it either way. Let's use cos. Cos theta is adjacent over hypotenuse. Cos 30 degrees is x over 30, because now we know why. Cos 30 is what? Root 3 over 2. So 2x is equal to 30 root 3, and x would be 15 root 3. Right? Or Pythagorean theorem. No, x squared plus 15 squared. 30 squared, so x is equal to the square root of 30 squared minus 15 squared. Wow, this is harder. 900 minus 225. What's that? I need 75 to get to 300, so 675. What goes into that? 225. Hey, it's all done. And I get my pencil back.
Yes, of course.
Yeah, well, a lot of times I will not get pencils back.
I'll see you last class in the field.
No, it's after lunch. Actually, at the break. So you can come at the beginning of the break if you want to start early.
Okay. And that's for which room?
3:02. I'll send out a reminder. Keep your phone handy. Like, I have to tell you guys to keep your phone handy. Okay. Question. This was easier, right? This. Because it was already reduced, right? Everything was reduced, didn't have to do anything, you know. But either one works. Like, who cares, right? You're doing math. So if it says determine, what does that mean?
Show your work.
Okay, that's the third thing that'll make me happy. By the end of the year, if you know that determine means I must show work, the answer alone will get me approximately half of the value of any particular question. Well, apparently I do have to tell you to keep your phone handy. C, 45. So important thing. So what's 20? I mean, give it a name. Hypotenuse. I always like to do the hypotenuse first, right? Because it's fixed, right? What's x? Doesn't really matter, you know, because this is also 45. So we'll call it adjacent, because it is adjacent to this 45. But sine 45 and cos 45 are the same, right? So whether we use the sine or cos ratio, it's still the same value. Okay, so what do we do? What are we using? Adjacent? We're using cos. Cos theta is adjacent over hypotenuse. Right? Determine. Show the work. Show me the formula. I'm using the cosine ratio, right? It's adjacent over hypotenuse. Okay, my angle's 45 degrees. See, cos 45 degrees is equal to the adjacent side is x, and the hypotenuse is 20. The cos of 45 degrees. Now you decide 1 over root 2 or root 2 over 2. Which one? You got a 50-50 chance of getting it right if you just randomly guess. So think about what you're going to do, right? We're going to take the bottom number, multiply it by x, and then divide by the bottom number, right? So we're either going to end up with root 2x, but if I divide by the bottom number, I don't want it to be a radical. So we're going to go with root 2 over 2. So root 2 over 2 is equal to x over 20. It's not a big deal if you use 1 over root 2, right? It doesn't matter. It just means you're going to have to rationalize. So 2x is equal to 20 root 2, and x is 10 root 2. Okay, exact values, no decimals, right? What are the three things that make me happy? Exact values, no decimals, right? Just radicals and stuff. Determine, show your work, right? Because on the final exam, there's written stuff. It's going to say determine. I don't want to see you lose marks because, well, obviously you knew what you were doing. You got it right. What's the fourth root of 81? Plus or minus 3. It's worth a mark if you know that it's plus or minus 3. Actually, it's worth 2 marks, but it's worth 1 mark if you only know it's plus 3. Plus or minus 3. Okay, this one. What do we got? What's 8? Adjacent. What's x? No, it's 8. Well, okay, sure, it's opposite. It's also 8. It's an isosceles triangle, right? So the sides opposite the 45 degrees are the same. What's y? Who needs this trig stuff, right? It's just the square root of 128, which is 8 root 2 or something. But let's use this trig stuff. Okay, let's use cos because we do have the adjacent. Let's tell whoever's marking this that we are using cos. That's me, by the way. I should outsource it. I probably could. I'll scan it all in and ship it off to India and get it back. It'll cost me $5 or something. Just start doing it. Right? Free up your evenings. What's cos of 45? Root 2 over 2. Which one do I want? So if I use root 2 over 2, and then adjacent is 8, and then hypotenuse is y. Now if I do that, I'm going to be dividing by root 2, right? Because I'm going to get a root 2y. So let's do this as 1 over root 2. So what's y? Well, 8 root 2. Done, right? Save the problem of having to. If you wrote it as root 2 over 2, you got to divide by root 2 and then re-rationalize it, right? And you're going to get 8 root 2. It's going to take a lot more work. Okay. Here, let's do it. We'll do it with root 2 over 2. Root 2 over 2 is equal to 8 over y. Root 2y is equal to 16. Y is equal to 16 over root 2. Y is equal to 16 root 2 over 2. Y is equal to 8 root 2. So, your choice. This or this. Does it matter? I ran out of time. Well, here's why. Right. So if you look at it, just say, what am I going to multiply the variable by? I do not want to multiply the variable by a radical, right? If I do, then when I divide it, I'm going to end up with a radical in the denominator and have to rationalize it. Okay. Now you could go from this to this, right? I mean, like, you know that that's going to be a 2 on the bottom, which will go into the 16. But if you say, hey, if I can take the variable and multiply it by a number, then I'm just going to divide by that number, right? Dividing by a number, I won't have to rationalize. So when you go to set this up, write this first and then just say, oh, with cos, right? I mean, it's only cos 45. That's the only one that you have this choice, right? And tan of, the tan that's 1 over root 3. Which one's that? That's tan 30, right? So it's only cos 45 and tan 30 that you have to worry about this. Okay, and it's not a huge deal if you don't do it, you know, the optimal way. You're just looking at a few more steps. Wait, there's more. How much more is there? Oh, there's 2 more. This and then like an entire page. That must be a huge question. Yeah, apparently, right? It's like the entire page. Probably it's a 2-line solution. Okay, how do we get x? We're actually going to learn a neat way to do this, but we don't know that yet. So given what we know now, how do we do this?
You define the opposite for the triangle on the left.
So
So like the
which opposite? Where's this opposite?
like the one in the middle.
This thing?
Yeah, you define that.
Right. Okay, so let's call this h for like height, because it actually is the height of the triangle, right? Okay, so we could do that, right? Because we got the 30 degrees and we got a 15 on the bottom. So we're going to solve the right triangle, which is a right triangle, for h. And then we're going to use the h with the 45 to solve for x, right? So we'll just do a double kind of solution here. So within the right triangle, we have 30 degrees, we have opposite, and we have adjacent. So we're going to use which? Tangent. So we're going to say the tan of 30 degrees is equal to opposite over adjacent. Okay, now this is where we get to make that decision of which form of tan, right? So let's first fill in opposite and adjacent. So h over 15, which means I want the h to be multiplied by not a radical. So instead of 1 over root 3, I'm going to use root 3 over 3. Right, now we get 3h, 15 root 3, and we get h is 5 root 3, right? Let's write it out. 3h is 15 root 3, and h is 5 root 3. Now, that's an exact value, right? And we are then going to use this exact value, 5 root 3, in the other triangle, the left-right triangle, because the left triangle is also a right triangle. So the left-right triangle here, 45 degrees. We got h and x. What are they named? What's h? Opposite. What's x? What trig ratio relates opposite and hypotenuse? Sine. So start off with the formula, right? Sine theta is opposite over hypotenuse. Substitute in. Sine 45 degrees is equal to. That way it's just, it doesn't all of a sudden appear, right? Like sine 45 just all of a sudden appears. I sort of wonder how did that happen? You know, where did that come from? You know, but you're showing me, look, I'm going to use the sine ratio now. Okay. What angle? 45. Where did that come from? Well, there's only one place that could come from. Okay. Opposite, h. Now you've labeled that on your diagram. Okay. But h is 5 root 3. So we can go 5 root 3 over hypotenuse, which is x. Okay. I want, because 45, we got a choice, right? Root 2 over 2 or 1 over root 2. What is the choice? Wrong choice. 1 over root 2. Okay, what was the rule? The rule was, when I cross multiply, I want this to go with a number, not radical. So 1 over root 2. You wouldn't get it wrong if you did it the other way. Well, I'm not going to say that. You may get it wrong, but you know, you'll just have a little bit more work to do. Okay, so if you can optimize things, right? So if you say, wait a second, but don't spend 20 minutes trying to know which one should I do. Like, just do it. If you choose, in quotes, wrong, which is just, it's not wrong, it's just non-optimal. If you choose that, it's just going to take a little while longer. Okay, what's x? 5 root 6. Okay, no units on there, right? There were no centimeters or meters or anything like that. So, you know, on written response, just write in the units regardless. Just, you know, if there are units involved. We could say units, but I don't think we need to bother. Okay, one more. You got an entire page. The rear window wiper blade is 48 centimeters long. That's pretty big. Must be a large rear window. Because on my car it's like 16 inches, and 16 inches would be like 32, 40, be like 40 centimeters long. Anyway, the blade moves between an angle of 30 degrees and 135 degrees. Determine the exact value of the horizontal distance that the tip of the blade moves in one swing. All right, what should we do? Draw a diagram, right? Because you could plunk down numbers. Oh, a sine of 30 is, but you know, you need a plan. Actually, you need to understand. And what's part of understanding? Let me draw a picture.
Visualizing.
Yeah, visualizing, right? So even if you can do this in your head without, take pity on me because I can't, and show me a diagram, right? I want to understand what you're thinking. Do we care if you get the right answer? Yes. Yeah, but what's it worth if you get the wrong answer, but you just made one tiny little mistake? Questions out of 3, what are you going to get? 2.5. Maybe 2, depending on how egregious the error was. 0 if you squared a binomial and got 2 terms. Right? That's just the unproved. Sorry. Yeah, nope. You can't do that. That's the NHL rap. You can't do that. Not allowed. Okay, so let's draw a little coordinate thingy here, right? And we've got 30 degrees. And we've got 135 degrees. So there's my 30-degree angle. And this guy is 135 degrees. Okay, and here's the blade, which is 48 centimeters long, and it's also 48 centimeters here. And what do we have to find? So what else do we need to draw on this diagram? Exact value of the horizontal distance. So where is this horizontal distance of which we speak? Well, of which it is written. And so it is written. Which way is it going? So horizontal, is that like across or up and down? It's across. Okay? So where am I drawing? Across. Across. There. So we want to find the red distance, right? The red distance. The horizontal distance. Okay. We need the exact value. How are we going to do this? Oh, next week we'll get away. It's just so easy, right? But it's not so easy now. There are ways you know not yet, but you will. But in the meantime, let's solve this. So, what are we going to do? So what would it be handy to know?
The angle between the two lines.
Okay, what's the angle between the two lines?
135 minus 30.
Okay.
So
105?
5, yeah.
105. What's that? Smoke. That would be really handy to know next week when we have a way that we can solve this. But we don't know it yet, so. It's 30 on one side. What is it on the other side? What's the reference angle on the left? Okay, which is? Okay, so this angle here. All right, so we've drawn the diagram and we have listed all possible knowledge, right? We got a 30-degree angle, we've got 135, the angle between the 30 and 135 is 105, the reference angle for the first one is 30, the reference angle for the second one is 45. Now, what do we got to figure out? Get the horizontal distance. How are we going to do that? What do we need? So what do we need to know here? Which value? It's an ordered pair, right? Like this here, it's on a plane, right? We know this is 48. There's an ordered pair. Which value would it be handy to know? The x. And then over here, the x. And then what? Find the distance between them, right? Just subtract this one from that one, right? Or you can just say, well, this distance is blah, and this, although it's negative, its distance is actually positive, and then add those two together, right? Okay, so we need to find x. We need to find x1 and x2. Okay. We don't care about the y's, right? Because we want the horizontal distance, right? How far does it travel per line? So if you saw the sweep of the blade, right, which is actually moving on an arc, you're saying, but what's the distance between the endpoints on a horizontal line?
So if you just draw lines to make it into a box, you have your angle and
Perfect. So Draw a line to make a box. We got right angle triangle. So this one has a 30 degree and a 48, and we want to know x1. So in terms of 30, 48, and x1, what are we using? Which ratio? Cos. So we're going to say cos theta is adjacent over hypotenuse. We're going to say the cos of 30 degrees is adjacent, which is x1 over 48. We need to figure out x1. What's the cos of 30? Root 3 over 2. Dang, ran out of ink. Yeah, I know. It's not so smart. Okay, so what do we get? 2x1 is 48 root 3. So what's x1? 24 root 3 centimeters. Now there are units, right? So we have worked out this distance is 24 root 3 centimeters. What's the next thing we're going to do? Find x2. How are we going to do that? Which trig ratio? Sine, cos, tan, secant, cosecant, cotangent. So we got 45 degrees here, right? Okay. And we want to find this, which is just cosine again, right? So I'm not going to rewrite the cos theta. I don't need to do that, right? So I'm going to just go over here and just say, okay, the cos of 45 degrees is x2 over 48. Okay, so this is my unknown. I want not a radical on the bottom, right? So I'm going to use root 2 over 2. So 2x2 is 48 root 2, and x2 is 24 root 2. So what's the horizontal distance? The horizontal distance. If it's a word problem, it's always good to just end it with a sentence, right? I mean, they're asking you to find something, right? Which is, what is the horizontal distance traveled by the tip of the blade? And all you do is you repeat the question as a declarative statement, right? In other words, you just take off the what, and you say the horizontal distance. Did they say what did they say? Determine the exact value. Okay, so you could say the exact value of the horizontal distance that the tip of the blade moves in one swing is, or the horizontal distance is, horizontal distance moved by the tip of the blade is what? Come on, bring it home.
Two things added?
Yeah, the two things added together. Wow. It's like, hey, we got that far. So 24 root 3 plus 24 root 2 centimeters. You don't need to factor it out. Maybe just put it in brackets like this. So that's the whole thing. If you wrote 24 bracket root 3 plus root 2, then I'd be okay with that. Right? I'd be taken aback at first. Oh, take that. Okay. It wouldn't look like my solution. I always look at your answer and say, does that look like my answer? Yeah, okay. Is there work that justifies that? Yeah, okay. They didn't show any work. Now what am I going to give them? It said determine. I mean, legitimately, if it says determine, you just give the answer. Legit 0, right? Like, I don't think you can argue it a whole lot. Where'd you get that from? I looked over at this paper and I just wrote down. Okay. Is that it? Good. Any mistakes on here before I hit done, and then it's just real pain to correct things.